There we go. Thank you, everybody. This is the September installment of the Microsoft Data Platform Continuity Virtual Group. I cannot believe how fast this year is flying by. It's just crazy. We have a slight speaker change today. Our topic is going to be disaster recovery strategies for SQL Server, and it's going to be Anthony Nocentino. So with that, I'll turn that over to Anthony.
I mean, you said speaker change. I think you mean speaker upgrade,
There
right?
you go.
Yeah. No, just kidding. Hey, everybody. Thanks for joining. I am Anthony Nocentino. Thank you for having me, Chris, David, to talk about disaster recovery strategies for SQL Server. If you signed up for the live session, you were probably expecting this handsome young man, Andrew Prusky. He unfortunately wasn't able to make it today, so I am pinch hitting or filling in for him. But just to give you a quick background on Andrew, he's a Microsoft MVP, VMware V expert, Docker captain, a co-worker of mine at Pure Storage as a field solution architect, where he focuses on SQL Server. He blogs a bunch. Certainly, you've probably read one of his blog posts over the last 10, 15 years since he's been doing that. And he's a fantastic friend of mine and super excited to be able to do this presentation. I'm Anthony Nocentino. I'm a senior principal field solution architect at Pure Storage. I have the longest title at Pure Storage. I specialize in system architecture and performance. So jokingly, I like to say I love to design systems. I like to make things go fast. And that's kind of where I've spent most of my consulting career before I came to Pure. Now I make things go faster because we have really cool storage devices, but we're not here for that. I'm also a Microsoft MVP. I've been so for, I think, 8 years now, and several folks I can see on the call are as well. So why are we here? We're here to talk about DR. And I think the key thing to know about DR is one, that DR stands for disaster recovery. Really, what it means is how do you recover your systems when things go wrong? And the idea is when things go wrong, because it's going to happen, right? We've all had to, or hopefully, I mean, actually, hopefully haven't had to, but we've all probably have had to enact some sort of recovery strategy over our careers to recover a system that's failed, to recover from a site that's failed, or even recover from a cloud region that's failed. And kind of the nexus of this, or the foundation that Andrew built this presentation on, is this idea from the Google SRE team that hope isn't a strategy, right? We want to apply solid engineering principles to disaster recovery such that we can recover our systems in a deterministic way, the same way, bring them back in a deterministic amount of time, the same amount of time or predictable amount of time, such that we can say to the business, here we go, let's get back into business in this window so that we go on doing the things that our business needs to do. And we've seen this in the public eye a bunch over the last couple of years, right? We've had major companies, Netflix, Facebook, GitLab, Google, all the big players in the game have had outages over the last couple of years. And it's not anyone's fault. It's just these are complex distributed systems that are managed by people, right? And people and processes and systems. And that's really going to be the big focus of today. I mean, I've been a party to many an outage inside of Azure. Dropbox has been down, Zoom, Adobe, Salesforce, and we were talking about before the presentation, before we went live, the big one that we probably all remember from this summer, CrowdStrike. Luckily, I was on vacation in Italy, and I had a bottle of Chianti with me when this all went down, so I just closed my phone and went back to doing what I was doing. But that was a real thing that impacted a lot of business. And one of the things when I talk to our customers at Pure, especially around this CrowdStrike concept, is that really has changed the game on how we have to think about failure, right? You won't, like, before that, I think, even if we go back to the days of antivirus, we just took the update because we knew it was the latest and greatest, right? That's going to protect our system the most. It had the latest signatures. It did the things that we expected it to do. But if you think about where something like an antivirus mechanism sits or CrowdStrike sits in your stack, you would never think about that from a fault domain standpoint. Oh, this is a kernel mode driver that has privileged access to a thing that's going to cause my operating system to crash. That's a very finite thing, right? But once you allow that external control over a system, that's a change that you have to manage for over time, right? And that's what we're going to focus on today as we get later on in the session, is how to measure in those changes and how to continuously test so that we can surface those things out in failures, right? If we were live in a room, you'd see Abraham Simpson come along and say, it'll happen to you. And that's what we see, right? It's going to happen to you eventually at some time in your career where you're going to have to enact a DR plan to recover your business, right? And so what do you do? Well, really, it comes down to two things: planning and testing. Oh, wait, but continuing to plan and continuing to test in an iterative way. And that's super important. I've seen multiple times where a HADR system goes into production with some assumptions about infrastructure. Something changes in the infrastructure, in a process. And then when you go in and act that DR plan, it fails, right? Because you planned, you tested once, something changed, and you didn't test it again. And so that's an iterative thing. We have to test at a periodic interval so that we know that we can fail over and protect our business. And so planning and testing is core to any DR strategy and doing it in an iterative way because our systems are constantly changing, right? We've all done it where something goes and we have to change this setting for this or change this setting for that, or a new product comes out. We want to integrate it into our environment because it brings some new business critical feature. You put that thing in, you need to test your DR strategy again because it's going to change. Think about the CrowdStrike example. Did someone test if a failed update was going to bring down a platform? Probably not. I've seen network changes that bring down quorum and infrastructure, right? We have a cluster that expects maybe multiple paths out to the internet to hit a cloud file share witness. Those things can change even outside of your control as a DBA. And when you depend on that cloud file share witness, it might not be there because of an infrastructure change. So that's one of those examples that you really want to be able to kind of surface out in your testing strategy. So, uh, DBAs, right? Usually I would ask like, who are the DBAs on the call? I'm a safe assumption a good chunk of us are. So DBAs have a couple of jobs, right? Availability, recovery, and performance. All right. And I think we kind of think about these as independent things, right? My system's up. I'm able to recover my system. It's well performing, but they are 100% interdependent, right? And availability strategy is completely dependent upon the performance of the system. And you think about the performance of the system in terms of things like query throughput or how long a query takes to execute. That might be part of your service level back to your business. I need to be able to conduct X number of transactions per minute. If I can't hit that, that performance issue actually becomes an availability issue. What if you have blocking on a user table and the user can't log in? That's an availability issue, but it's kind of a performance issue, but it's kind of an availability issue. And so we need to think about systems as a whole, right? Focusing on availability, we think about things like failover clusters and availability groups. Recoverability, we think about things like backup and restore and log shipping and all those things. And performance, we think about query tuning and how fast my storage array is and those things, but they're all completely interdependent when you're building a recovery strategy and an availability strategy. And so let's look a little bit at what high availability really means to a DBA. And most often we think of it as like, well, we just like to keep things running, right? Like Forrest, we got to keep this thing running all the time to protect our business. And well, that's the thing that we measure in the number of nines, 3 nines, 4 nines, 5 nines, 6 nines, and so on, right? Because that's going to be established by the redundancy of the system. We're going to build in some sort of physical redundancy to protect our system in the event of a failure, right? Back in the day, we used RAID stripes to protect data files. We'd use multiple teamed NICs out of the server. We'd use trunks between our switches and our infrastructure to protect the system so that it could always be online. Because what we're doing here is we're protecting kind of against localized damage. If something goes wrong on a failed drive or a top rack switch fails or a network card fails, those are the kind of things that you're thinking about when you're planning within a fault domain, how to protect and keep that individual system online. When you think about disaster recovery, because I really want to tease out the difference between these two things is what do you do when something goes wrong in a very significant way? An entire region goes down in your cloud, an entire data center goes down in your business, your private cloud, maybe. I've seen other customers that have had complete power outages within a region of a state, which takes down their primary and secondary sites. So these are the kind of outages of that kind of magnitude that we need to plan for. Recovering from significant events, right? And generally means that something is down for an extended period of time and you're dependent upon moving your workload somewhere else. I need to pick up my business that was running here and move it over there, generally in a geographically dispersed area, maybe New York and Las Vegas. You think about if you look at Azure regions, especially the Azure region pairs of things like Central US or East US too, and looking at how you build an infrastructure that's physically divergent and also independent fault domains. And one of the things I think that we often forget as technologists is that a DR plan And executing a DR plan is not a technology decision. It's implemented in technology, 100%, but it is a business decision to go to DR because it's business impact, right? It's hard to do. It's hard to pick up a workload and move it to another site. And it's also hard to move it back. And we'll talk about failover and failback strategies today. Cool. So I consulted for a long time. And the two hardest questions to answer my customer base is I'd sit in a room and say, how much data can you lose? How long can your systems be down? And what's always the answer, right? None. I can lose no data. I can't be down ever. And I'm like, cool, that's great. Here's the system architecture, and it's got two commas in it, right? You know, over $1 million, right? Or US dollars. And so that's an important thing to understand. If your business actually needs that level of availability, you can engineer for it. But is it worth that to the business, right? If you can provide 5 minutes of downtime and 5 minutes to recover, and it's a $500,000 solution, that's going to be a lot more attractive to the business. But that's going to be what you really need to tease out from your business is what is the cost of downtime? And why my screen is frozen? What is the cost of downtime? And what does that mean to be able to bring the system back with the technologies and capabilities that you have? And so let's kind of get a little more formal to the definition of these things. So recovery time objective, often referred to as RTO, is how long it takes to recover the system, right? That means when a failure occurs, what's the maximum amount of time that the system can be down that the business can tolerate. I once worked in the legal industry as a consultant for a long time. Well, I worked as a consultant for a long time. I worked in the legal industry for a bit. And they had a system, probably the second most important system at a law firm is timekeeping because generally attorneys bill by the hour. And I asked what the recovery time objective was for the system. They said 24 hours. I'm like, but you identified this as the second most business critical system. And they're like, yeah, we did. But their application could operate for 24 hours based off of a cache that it would have in a distributed system. Oh, okay. So yeah, you really do have a 24-hour window to bring that system back online then because the people could still function and they would just sync their time back within the billing interval. Right. And so even though it was the second most critical system, it had a recovery time objective that was pretty long, kind of in technology terms, but it met the business objective. So we didn't need to build an extraordinarily sophisticated solution to solve that problem. If you're wondering what the most critical system is, it's generally the document management system at a law firm because that's the actual work product of attorneys for their clients. That one had a lower RTO. So, but that was defined by the systems architecture. And so, what that really means, and as I kind of touched on this topic, is that defines the recovery strategy to be used, right? I didn't need to have a sophisticated thing to recover that second most business critical system. But for the most business critical system, we had synchronous availability group replication, we have asynchronous to DR, we had all that stuff you'd expect because it was needed for that particular application so that it could recover in a significant port or recover in the required RTO. One of the challenges when you start to build complex infrastructures is they become more challenging to scale, right? And so that's what we're talking a lot about at the end of today's session about scaling and testing. But as you build things like availability groups, and especially for a relational database that's generally a scale up implementation, those things can be more challenging to run and maintain and engineer, right? I'm sure we've all had challenges with things like log redo, or maybe our network infrastructure can't keep up with the replication of data between replicas. And these are things that can impact the recovery of a system. Now, let's look at another dimension, how much data you can lose, or the formal term is recovery point objective, or RPO. And it's generally going to be defined in terms of time. Now, the RPO of that, the time tracking system, very low. Like we don't lose any data because if we lose data in a time tracking system, that means we can't bill for that, which means we can't make that money, right? And that's what feeds the business, which keeps us all employed. And so that particular system, although the RTO was high, the RPO was extraordinarily low. I had to make sure that we were able to meet that in terms of time. And when you look at kind of the foundation of a recovery strategy, backups are 100% kind of the bare minimum base thing that we have to do. And as DBAs, we're familiar with this concept because I think we're, with the idea of a transaction log backup, we take those at a periodic interval, right? 5 minutes, 10 minutes, 15 minutes, an hour, whatever it is. defined by the business. I can lose an hour's worth of data. Okay, well, I'll take a log backup at least every hour, right? If not more frequent. And that's the recovery point. If I restore that system, the maximum amount of data I'll lose is that 1 hour of data between those lock backups. If I need that to be more aggressive, then I would dial that down to a more frequent interval. I've seen some customers that actually run log backups even in a hard loop. As soon as they finish, just run it again, right? And that's a way to minimize the data loss. And that's a brute force way to really get that data between to recover that data for a low RPO. And we'll talk about some, I guess, more elegant or sophisticated techniques to protect a low RPO system today. But looking more closely at backup and restore, one of the things that we really need to focus on when we think about this is you don't have a backup strategy. You have a restore strategy. Years and years ago, I had the fortunate experience of going to a SQL skills training with Kimberly Chirp and Paul Randall. And Kimberly gets up, teaches a day and a half on backup and restore in a 5-day class, right? So that tells you how important it is from a DBA standpoint to have a well-rounded deep dive into that type or to backup and restore technique. And Kimberly makes this exact statement when she's teaching. You don't have a backup strategy. You have a restore strategy. We focus so much on backups and getting backups done. I think we forget that the outcome of a backup is the outcome of backup really is to get the data back, get it back online and focusing on that and engineering for that. And I'm going to talk about some really cool things that have come down the pipe in terms of some infrastructure ways that we can leverage backups, or excuse me, leverage uh, storage capabilities to do accelerated restores. When you look at backups, I think as DBAs, we've used this strategy for years. The kind of the traditional backup method where I scoop up all the data out of the database and I write it into a file. And then I keep a copy of that file, ideally on a separate physical infrastructure in my data center. And then almost immediately, I should have that replicated out of my data center to another site, right? So I have the primary copy running the real workload. I have a physically adjacent copy for a high-speed restore, and I have another copy offsite as soon as possible for DR in the event that that site goes away. Now, when you think about what you're doing there, you have to take into consideration the networking associated with that topology. I have to have sufficient networking to back up to secondary storage. I have to have sufficient networking to get that out of my data center within an appropriate amount of time to meet the recovery objectives. If I have a 100 terabyte database and it takes me 16 hours or 60 hours or whatever it takes to back it up within the data center, it takes me just as long to restore it, but I have a 4-hour RTO, that's an SLA violation to the business, and I need to do better. And we'll talk about some good techniques to manage that in a second. Similarly, if I have 100 terabytes, I got to land on primary storage, and I got to ship that out of the data center to get that to another site. And I might have to have or I have to have the networking capacity to do that, or I have to have some intelligent infrastructure that maybe just moves the change blocks to that target site so that I can meet those aggressive recovery objectives. We also need to make sure that we're testing at the remote site. So I want to pull a backup and restore it to make sure that I can actually bring that backup online, because we hopefully have heard this before. You literally don't have backup unless you've tested your restores. Kind of that concept of like Schrodinger's backup, right? The other thing I evangelize a lot um, when we're talking about enacting DR plans and even just restoring a database is when I need to restore a database, the last thing I want to have to do is think, right? So Andrew in his slides here has runbook prepped to enact restores, 100%. You need to mash the button, hit the script, whatever it is that is an automation tool to execute that restore for you. I'll freely say I've written, since DBA tools has come out, my T-SQL skills have plummeted into the garbage can. My PowerShell skills have taken off, but I am 100% dependent upon DBA tools to do restores in systems now because of the way PowerShell, and I love to use PowerShell to be able to do those types of restores. But more importantly, I can take the DBA tools commandlet, I can point it at a stack of backups and generate the restore scripts or actually run the restore. So now I have two artifacts that I could use. I generate the restore scripts and put those in source control, or I can enact the actual script to do the restore for me in PowerShell. And the idea here is not having to actually think about what you have to do when you need to do it, because we need to be able to do these things, 2 in the morning when our alarm clock goes off or our pager goes off to wake us up to make this change. RTO, how long it takes to come back online, is going to be dictated by the size of the database. The bigger the database, the longer it's going to take. And there's a lot that goes into how fast the database restores. And it's not just the network pipes between where the backup sits and where the SQL Server instance is. It's the clock speed in the CPUs. It's the network cards. It's potentially the PCI bus in the host that the VM is on, or if it's a bare metal box, the actual server itself. It has to do with the storage infrastructure going into that. All of those things go into your restore speed. One thing is even the tuning of the actual backup with multiple readers and writer threads across volumes. And those are what techniques that we can use to attack RTO. So think about backups, right? What we've done over the years is, like, as I said a second ago, it's the size of data operation, and it takes as long as it takes, right? And it puts a bunch of pressure on CPU disk and RAM, or CPU disk and the network involved in the restore. It could potentially can impact your workload in the sense that, well, I'm putting pressure on disk subsystems, I'm putting pressure on networks, and putting pressure on CPUs and potentially shared infrastructures, right? I could have a VMware environment that has multiple VMs sitting on a physical server and they're sharing all of that. Or I could have a dedicated server, but I'm still sharing the backend network. And so that can impact your actual your end user's workload. There's also the time associated with this, having to take and replicate and all the things that we talked about earlier. But ultimately, it comes down to RTO, how fast I can recover this thing with full backups. And so for years, we've taken backups, we scooped them up, we've written them out the file, and then we turned around and restored them back into the instance. But in SQL Server 2022, Microsoft introduced a new capability called T-SQL Snapshot Backups, which allows us to restore a database almost independently of the size of data, right? Because we can take a snapshot of the disks. And I know like all those old school and hardcore DBAs and the calls just rolled their eyes, snapshots. But hear me out. In 2022, the game has changed, right? In SQL Server 2022. In SQL Server 2022, Microsoft took the ability to quiesce the database out of the hands of VSS and any external tools and put it straight into the database engine. Right. So the database engine is in charge of this entire process. Right. So SQL Server knows when it's going to freeze and thaw a database. Once you freeze and thaw the database, you can take a snapshot at the storage tier or in the cloud if you're using cloud storage. And with this technique, especially different from what we've seen before, is it unlocks this idea of point in time recovery. So now if I have that 100 terabyte database, I can revert it back in time instantly, put it in restoring mode and restore log backups now. And so I can do that for a database, a group of databases, or a whole server. I know it's an instance, but the documentation for this feature says server. So I'm just being precise here. We can also seed availability groups and log shipping replicas using this capability. And also, this is it's a cross-platform technique, whereas before VSS was just on Windows, now we have the ability to take snapshots on both Windows and Linux because the database engine is in charge of this. And it's extraordinarily fast when you compare it against previous technologies like VSS. And it's also, amazingly, only going to stun writes. So you can still read from the database, right? Which is very much so different than it was in VSS. And the freeze is also going to be a deterministic amount of time, where in other implementations, you have some challenges around what VSS would do in terms of the duration of a freeze and the thaw. It's a super interesting feature here. And I'm not saying to replace your snapshot or your backups with snapshots, but definitely take this into consideration for the biggest and baddest databases you have in your environment where backing up is hard and restoring is hard, right? Think about the business value of reverting the database 100 terabytes instantly, or even 10 kilobytes, any size, takes the same amount of time, and then being able to bring that back to the exact point in time of the failure. I've blogged a whole bunch about this on my blog at nocentino.com. And so there's a link to get into that there. Cool. All the syntax and examples and all those things are available to you on the blog post around point in time restore and also some more advanced configuration. So as we move away from backup and restore, let's kind of move, I don't want to say up the stack, but maybe move it a closer to real time system of DR, log shipping. This quite literally is Andrew Prusky's favorite topic, right? When it comes to enacting a DR strategy. What log shipping does is it takes the changes from a database that are written out into a log backup, as you would normally take. Then it takes that backup file and it ships it across the planet through Africa, down to South Africa, over the Indian Ocean into, I think that's approximately Perth. No, just kidding. But it basically you take the backup file and you ship it to another instance over regular old networking. And what happens is that other SQL Server instance cracks open that log backup and restores it to that target instance. So now you have your production OLTP system and you're shipping the information or the changes to another replica. It's a very mature decision. It has been tried and tested. It's been in many versions of SQL Server. And it's really a way to a core way for DBAs to protect a system when there are no other capabilities available to them because it's part of SQL Server. I think jokingly, if Andrew was here, he'd make this joke that any DBA worth their salt has built their own log shipping mechanism on top of the one that usually would come out of the box from SQL Server. But log shipping isn't perfect. It is a per database and per instance implementation. So the coding mechanisms can become complicated at scale, right? If I'm dealing with a database with dozens of or instance with dozens of databases and dozens of instances, this can be challenging to manage at scale. And also it means it has some challenges around the number of transactions it can ship because of the volume of being able to move that data over the network. But it does have an interesting, I guess, side effect of what it looks like from a recovery plan standpoint. Uh, Andrew calls it delayed applications of transactions. What this means is the recovery point is the log shipped interval. So if I'm shipping every 15 minutes and my replica to target site is 15 minutes behind, but let's say I have an error that happens 8 minutes into an interval before the log backup gets taken and gets shipped. I could stop log shipping and prevent that error from going to the DR replica and enact DR. And so that allows you to kind of have a more flexible recovery point so you can get back to a previous transaction, maybe recovering from human error. So log shipping writes the log backup out, sends it over the network over Windows networking or CIFS or SMB, like the actual protocol to ship that across the wire. And it plays it back at the target site. But Microsoft took this idea and extended it. And so rather than writing the log records into a backup file and shipping it, what if we just wrote the log records directly into a network socket and sent it straight to that instance at DR? And that's what mirroring is. Mirroring takes log records or changes from a primary instance and sends them to a secondary or mirror at another site or in the same site so that you can keep them in sync. And there's two ways it can be done in high safety mode, which is synchronous, meaning if I change something on the primary, it's going to be changed on the secondary before and acknowledged back to the primary and then up to the client application. That's definitely going to be an or HA technology, an availability technology. I can switch it to what's called high performance mode, which is asynchronous replication. This is generally used between sites as a DR capability. And so now I can still have my transactions committing locally, but then shipping to the target site asynchronously. But there's no guarantee that a transaction is made it to the target site because it could have a failure somewhere along the way. And so what we do here is we have the ability to have two replicas within a site or between sites, and you control failover again at the database level, much like log shipping. And so that also becomes a little bit challenging at scale as well. And you also have to go and dig a little bit deeper into mirroring when it comes around custom performance metrics in terms of looking at things like the overhead of mirror commits. Mirroring has been deprecated. I know that. We all know that. And it's been replaced with availability groups, but it's still a valid capability. It's still in the box. You can still use it. I mean, you're not going to get any new features or anything like that, but it is a good way to get data between sites when you absolutely need to. Availability groups. So let's take that mirroring concept. And I like to say that availability groups is really like kind of like mirroring 2.0, where it's mirroring, but for a collection of databases. The unit of failover now isn't the database, but it's a collection of databases, which are referred to as an availability group. And you can have one or many availability groups on a SQL Server instance. The key thing is here that the databases within an AG fail over together. And so you can get some sort of level of transaction synchronization between those to protect and keep a system that potentially has multiple databases in sync. Now, rather than hitting the instance directly with a special connection string like you had in mirroring, you hit an IP address or an endpoint or DNS name that will follow the availability group across multiple replicas in its kind of, I guess, say mainline configuration or some other configurations where you can get a little bit more advanced around the connectivity methods. And one of the challenges, though, I think with AGs is when you start to expand that across sites, and that's what Andrew calls out here, stretching clusters across sites adds complexity, right? Because now you have to think about things like quorum within a site, but also between sites, potentially having to move quorum between sites for your cluster. And so that can become challenging over time from an implementation standpoint. Availability groups really, I think, have become kind of the de facto way for people to protect databases nowadays. But I still think a good failover cluster is totally situationally appropriate based on the customer requirements. But here's what an availability group looks like from the Microsoft documentation. We have data center one here on the left, data center two here on the right, say our primary site and secondary site. And in a traditional out of the box implementation of an availability group, you have a primary and secondary within a site. Those will generally have synchronous replication between the two, right? That's the one where we write our changes to the secondary, acknowledge back to the primary, and then our application moves forward in time. We can also have asynchronous replicas mixed in with that. So here we have two replicas at a secondary site that are being asynchronously replicated too. But if you notice here, there's something a little bit interesting occurring in the green line going between data centers. That's two separate log streams being sent from the primary site to the secondary site, and then the third one, obviously, between the primary and secondary at the primary site. So that potentially can add some excess pressure onto a network. It adds a complexity from the quorum standpoint that we talked about a minute ago. And so Microsoft took this idea and went another level and built what's called the distributed availability group, or DAG. Unfortunately, there's a DAG in the concept of exchange, which gets some folks a little bit mixed up. But we're talking solely about distributed availability groups within the context of SQL Server today. And so the idea here is I have an availability group of availability groups. And so basically, I have two clusters now, and then I connect those two clusters with a single log stream. We'll look at that architecture in a second. And one of the things that we want to call out here is that there's no delayed application transactions. Even though it's async, I'm not gating it like it is inside of log shipping. These are all happening between all of the replicas, leveraging the synchronization strategy that we decide in configuration. So sync within a data center and an async between data centers. And we also want to call out that a failover between data centers is manual, meaning somebody has to mash the button to do these things. So in a DAG, distributed availability group, you can see the fundamental difference between this and a regular availability group. Can I say RAG? Oh, wait, I think that's like an AI thing now. Tag? No, traditional availability group. I don't know. We'll figure it out as we go. But in this implementation here, you can see primary and secondary in our primary site, sync rep. There's a single log stream going to our DR site to another AG. That forwarder is what is the now an additional role of that primary at the second site, replicating to another replica. And so now you can see there's one stream going between sites. The forwarder is forwarding records to the other secondaries at that secondary site, putting much less pressure on the network and a simpler quorum model associated with this implementation from a clustering standpoint as well. Very cool. Very cool. So the very first time I got to see Andrew do this presentation at SQL Bits this year, one of the big feedbacks that he got, because Andrew was very much so focused on the on-prem implementation. So since he's added a whole bunch of cloud material, and so let's dive into what HA or what DR looks like inside of the cloud. When you talk about cloud, and I think we're going to keep this kind of focused on in the Microsoft universe of things inside of Azure, but we can certainly go into AWS a little bit if anybody has any questions or comments around that. When you look at the DR capabilities in Azure, Microsoft's done a really good job of trying to make a very complex thing as simple and out of the box as possible. And so when we look at the slew of services that fall underneath the Azure SQL umbrella, the SQL database, got managed instance and IaaS VMs, they all have similar outcomes, but really different names in implementation. So Azure SQL Database has the ability to have geo-replication, right? It can have up to 4 readable secondaries inside of a SQL database? Well, that's built on top of an availability group implementation. But that's kind of abstracted from you because you're consuming that as a cloud service. I can also have failover groups, which means I can fail over a group of databases between Azure SQL database servers, meaning I can move a group of databases between instances as a group, very much so like an availability group in that sense. Now, if I look at something like managed instance, also has the same idea behind auto failover groups. I can take a collection of databases or I can take a collection of managed instances and move them over at a point in time. We also have the ability to take on-prem systems now via a distributed availability group and send them into a managed instance over the MI link feature, right? So literally I can have an on-prem implementation of an AG connected to a managed instance and have my data inside of Azure and fail over to that and fail back when needed. And this really kind of highlights the value of the cloud, because one of the things about DR sites that's been challenging over time is the care and feeding and costs, right? So think about what you're able to do with the Azure SQL managed instance. I don't have to maintain the managed instance; it's self-maintained. I am only going to really pay for it when I need it because potentially the hybrid licensing scenarios that we have, if we have software insurance, I can have reduced costs there, and I don't have to go and maintain the physical infrastructure at my own data center now. So I think this is it's definitely a very new feature, but I think it's a very interesting feature over time as this service matures to provide a lot of value to a business to get their data into a DR site quickly and efficiently. We also have kind of the normal stuff that we're used to seeing on-prem in the cloud when you use Azure SQL Server VMs or IaaS VMs. I have availability groups. I can build failover clusters. I have backup and restore, and I also have the ability to use a thing called Azure Site Recovery, which will replicate my entire VM and its networking config between sites, or excuse me, between regions inside of Azure. So lots of really cool stuff there happening in the cloud to protect our systems. We can also build hybrid solutions, extending those on-prem capabilities into the cloud, into IaaS VMs as well. So I can take those same SQL servers that I have on-prem AGs or log shipping replicas and replicate that into IaaS VMs with kind of my DR technology of choice, AGs, log shipping, whatever it is, or even transactional replication. But in those kind of situations, I'm going to have to be worried about the care and feeding of those VMs. So that goes into your kind of overarching strategy in covering system. So I think right about when this cloud portion got updated, this happened in the news. Unprecedented Google Cloud event wipes out a customer account and its backups. So what happened was this particular customer had their entire I don't know the term for subscription inside of Google, but their entire subscription was deleted. They actually were able to recover their business multiple weeks later by pulling backups from another cloud provider. And so they had to literally rebuild their business. And so a pretty crazy event that happened there, but also highlights the power and the risk of leveraging a cloud. One of the biggest things I find with the superpower of a cloud is the ability to do things at scale, and the ability to do things at scale in code, right? But what if you mess up? That's a very potentially huge risk proposition you have to be able to engineer around. So let's go ahead and move forward a little bit and talk about some other options. When we're talking about other options, let's focusing on the end result is I think really the real thing here is getting access to the data, right? So that we can meet our RPO and RTO. And so that's really, things like transactional replication or replicating a subset of tables between sites. I actually once had a customer when I was consulting say, like, what do you need out of the database to be protected? What's the most important thing? And they said literally this table. And it was a table that had a site listing of all the sites and all the phone numbers because their business continuity strategy could be affected with that information. Okay, I need to protect that thing the most. And really kind of honing, and that was a great conversation to have because it wasn't the customer that said, I have zero data loss and I can never be down. They knew their business and they knew it was important to run their business. And so that's really going to define how you replicate things. We talked about snapshots a bunch. Both Andrew and I have spent a lot of our time in the community talking about containers and Kubernetes. And one of the core things that Kubernetes sticks out for me when it comes to managing data is the idea really is all Kubernetes really gives you, or containers gives you, is an entry point into the data, right? I need a container to be up so that I can read the database. And that's really all we're doing with all these other capabilities and technologies. I need the SQL Server to be up so I can read the database. And think about the deployment mechanisms behind containers and Kubernetes. I can deploy SQL Server almost instantly. And if my data is there, I can get it online and I access the actual things that matters. The other thing I teach a lot and I talk about availability strategies, and I'll make this statement: nobody cares if SQL Server's online. Dramatic pause. What they care about is getting access to the data. So they don't care that your availability group failed over, but the DNS record didn't get updated, or the connection string what didn't have a login on that secondary replica, or that a top rack switch failed and brought down a VLAN and caused a 30-second outage. Nobody cares about any of that. Can the application get to the data? And that's the scope that we have to focus on in building an availability strategy. So we can't really build a strategy or have an availability strategy implementation without knowing what's going on, right? And so we need to focus on what are we looking for, right? Monitoring, alerting, being able to know what's going on in our system, recognize trends, and being able to enact changes if there is something anomalous, right? We talked about blocking in the beginning. That's an availability problem, right? And so we need to be able to think about what's going on in our environment and knowing that we're surfacing up the appropriate alerts and making sure that we're not contributing to alert fatigue. Number one rule in a monitoring system is the second someone has to build a rule in their inbox to move an alert out, that monitoring system is failing, right? Because an alert should be an actionable thing. You have to do something for it. Blocking, certainly an alertable thing. Is high CPU usage at Saturday night at 1 in the morning? Big deal. Maybe, maybe not. Could just be when backups are running. And so we want to make sure that we're alerting on the right things in the right way so that we can enact on those alerts. So I love using this expression, kind of the mash the big red button. It's such an interesting topic in a customer base. David, I'm sure you've seen this, and Chris, in your consultancies, and uh, you do at work. Some customers want to just mash a big red button to fail the whole thing over. They don't want to have to ring up the DBAs or call the SREs. They want to hit this giant big red button and it kicks off an orchestration engine to enact DR. Some customers don't want that. Some customers want the ability to have a SWAT team of DBAs to come in and make sure that that system is online, and they want that big warm hug when the DBAs say everything is okay. And so that big red button describes how you decide to enact that DR strategy. And it is going to be a way that let's see what we got here. I'm gonna guess. All right. We have that's going to go into how you build the plan, right? Because we're talking about technologies a lot so far, but plan is what you really do when. So some customers have very sophisticated VMware replication topologies. Those customers are probably going to want to mash the big red button. But maybe you have a complex physical infrastructure, those things that maybe you have storage replication and you have to get involved in DBAs and the storage team. That all goes into the plan as well. And so typically, this again is going to be a business decision. We also need to be able to define, again, how much data can we lose? How long is it going to take to fail over? What are the metrics that matter? When you look at availability groups, one of the key metrics that I looked for was transaction commit time on secondary replicas. And I would also measure that for SLA violations. So if the last commit on a secondary replica skewed, let's say, more than 15 minutes from a primary replica, I had an SLA violation because now I'm losing data. I'm losing at least 15 minutes of data if I have a failure at that point in time. And if there is something going wrong there, then I need to engineer better to smooth that out. That could be I'm out of CPU capacity on the log redo on a secondary replica, or the network pipe isn't sufficient, or the storage subsystems aren't sufficient. I have to go and find that thing out. The number one thing that we want to not do during a DR plan is really, I said it earlier, we don't want to have to think or have any confusion. This is a task that needs to be executed with precision. And also, what's the failback strategy? We often think about what's going to happen when we go to, but when everything settles and the dust and we can get back into business in a primary site, what happens when we have to go back? Oftentimes in DBA strategies, we have to scoop up all of the data and bring it back. And that could be a tens and hundreds of terabytes proposition in some systems. And there's some really cool technologies that can help you attack that problem directly. Awesome. Keep plowing forward. Chaos engineering. This is a very much so, I'm going to make fun of Andrew right now, a pet topic of his over the last couple of years. If you look up Andrew Prusky and chaos engineering on YouTube, he's probably got dozens of sessions about a deep dive into this topic and how it applies to taking rigorous engineering principles into availability testing. But we're going to focus on the DR part of things today. We're going to look at how we can apply these this chaos engineering strategy to DR testing. Because why? Failures don't happen at 9 o'clock in the morning after you've had your second cup of coffee, right? Failures happen at 12:07 at night when you've been at the pub for 6 beers, and then you go home and go to sleep. And then your pager goes off. Well, hopefully not if you're on call. I mean, there's probably rigorous rules around that, but you get the idea, the picture I'm trying to paint here. So chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. And that's a lot of words. What that really means is applying engineering principles to complex distributed systems, right? Because as we build infrastructures, gone are the days of one server sitting in a corner. And if the server was off or on, the system was off or on, right? Now we have distributed architectures. We have the ability of microservices. We have three-tier application systems. We have service-oriented architectures. Everything's dependent on networking and DNS and certain types of key credentials that are coming out of key stores. There's lots of different things flowing around in a complex infrastructure. The nexus of chaos engineering is implemented, or excuse me, chaos engineering is implemented at Netflix with a tool called Chaos Monkey, which is the way that they were able to take this idea of chaos engineering and apply it at Netflix is they built a tool that would randomly go terminate an instance or a server or a service in production, ensuring that the service that was being generated or serviced was resilient to that failure, right? So just imagine someone going through your data center, deleting the DNS record, pulling a network cable, putting a file system corruption on a drive, doing these crazy things that you'd expect. But those are the realities of what happens. But in this case, it's going through, and so you can measure what happens and how you can build a resilient system to protect against all those types of failures. Other implementations of this from Google and Slack, disaster recovery testing, DIRT, and then also disaster piece theater. So one thing we have learned is that the folks at Google and Slack and Netflix are very creative when it comes to naming things. In addition to building very resilient, complex distributed systems. And so what does it really look like? Well, for HA and DR, it's the idea is finding those weak points, right? Because those weak points are where it's going to fail when you have to enact your DR plan. And this is going to help bubble them out before in testing, right? And we also want to be able to know how likely is something to fail and what is the kind of the blast radius or the impact of a failure in a system. And also, this is a big one, reducing the friction of working with other teams. I, as a consultant for many years, my people would say my number one power was my technical abilities to solve problems, to make servers fast. No, the number one superpower I had was to go across teams to help solve the actual problem. And that's one of the things that we should focus on as DBAs is how do we go across teams to service the actual or solve the actual problems that we're trying to solve to help service our business. And then building experiments, right? Taking the rigor of kind of the scientific method and applying that to availability strategies. And what do I mean by that? Well, think about a failure domain, like what could break, and then break it, and then measure what that break or that failure was and how long it took to recover, and then build an automation around that to recover the system to bring it back, right? To do that, you need proper monitoring. You also need the ability to roll that back. And one of the core tenets of chaos engineering is using the tooling and techniques that you're familiar with in your environment. And so that then allows you to measure the impact of the failure, how long it takes to recover, how long it takes to roll back, and doing that in a way that is making that going to be better over time. Can I do this in 30 seconds instead of 3 minutes? Can I do this in 3 seconds instead of 30 seconds? And really kind of honing that down to what's most important to help recover the system as a whole. So, kind of bringing it all together, analyze the results, build actionable results so that you can build confidence in your system so that you have faith when you actually mash the button. And that's the idea behind applying those principles to DR. So, highly suggest watching Andrew's sessions on chaos engineering to really learn how to apply it here. Kind of went over it real quick from a concept standpoint, but really there's a lot of great ideas behind that when we're talking about applying that to DR. Mr. Prusky has a GitHub repo at github.com/DBA from the code/SQL Server DR, where you'll find the slide deck and some other interesting information. But for now, I am going to stop sharing and open it up for questions to anybody that has a question.
You've got a question, please drop it in the chat window. That was awesome. One, if you're an operational DBA, this should be in the forefront of your mind every single day. I'm not saying you have to think about this after hours or on the weekends, but it needs
Yeah.
to be in your forefront nonstop. This is the number one tenet of the job: protect the data. And
Mhm.
these are words to live by.
Pause.
Yeah. Well, if we don't have any questions, you've got his contact info. If you have any questions, if you're watching this on the YouTube recording at some point in life, do not hesitate to reach out to Anthony or myself or any of us at the HADR virtual group. Let us know. And if there's a topic you want to see in the future, one, we'll wrangle Anthony into writing and presenting for us, or one of us will write a session for you. It's a lot of fun. These topics come from you all. The topics are core and dear to our hearts. It's not glamorous. It's certainly not sexy, but guess what? This is the number one facet of the job: protect the data. I'm not exaggerating this. This morning, I was on a phone call with a group and we were going through a managed services provider's legal contract looking for availability because they broke their system. And you're absolutely right when you made that comment. Nobody cares if the database is up. The database came up, but the application wasn't. Business is still
Yeah,
down. We're talking 6 digits for this company for every hour that they're down of revenue loss. Um, Databases were up, app wasn't. Who cares? Yeah. And they've lost a
100%.
lot of customer confidence. They've got 20 retail locations. People walk in the door. Sorry, can't sell anything. They turn around and walk out. You think they're coming back tomorrow? Probably not.
Yeah, I think the situation I talk a lot, especially around performance engineering, is if someone goes to your website and adds something to your cart and a little thing just spins, adding to your cart, what are they going to do? They're going to go to your competitor, right? So again, performance is an availability strategy as well.
Yes, it is. There's a lot of overlap with all of that. A lot of people treat them as mutually exclusive, but it's holistic components for one big puzzle, and all the pieces have to come together in order for that puzzle to work properly. So you deal with third-party apps, and then all bets are off.
Yeah, you add that's when you add indexes. Oh yeah, I have a yeah, never mind.
I have an app. If you add an index, the app shuts down.
Yeah, I had yeah. So if I could, I would always I put a prefix in front of them of something I knew that I added and just torch
Yep.
them. I found a duplicate index once, and I was like, and I instead of like complete COI, I emailed support. I'm like, hey, can I delete this index? It's completely that's a complete duplicate of this other one. They're like, no. I'm like, why? They're like, it's referred to by its index ID in code.
Third-party apps. Gotta love it.
Third party apps. Yeah.
You're at the mercy, especially with HADR. An example of this, one I was dealing with yesterday. The license key for a piece of package tracking software has a component of it that is based on the SQL Server server name. So if you do
Oh,
an availability
jeez.
group failover, the application shuts down. So we had to request a second key from them and write a script that says upon AG going from secondary to primary role, update this entry in this one table, and then use PowerShell to reach over the network to restart the application server so that the app didn't shut down because of the license key. I don't need to make anything up. I have fact. It's always interesting. Well, if nobody's got any questions, and that was really, really good. So it
Yeah,
and
thank you.
answered a lot of the questions out there. So thank you. I'm going to go ahead and
You bet.
stop the recording. If you're watching this after the fact, thank you, and we'll see you at the next one.